I want to talk a little bit, obviously, about Kubernetes at the edge. And I don't really want to throw a bunch of information slides at you. I don't like slides. I come from an engineering background, and I much prefer like whiteboarding. So we're going to kind of dive into it and show some of that. But talking to people here at the conference, the number one question I got was, what is Kubernetes? And the number two question I got was, do I need Kubernetes? Oh, no, that's the wrong one. And it's not showing. There we go. Hold on. Aha. That's it. Do you need Kubernetes? And in the vast majority of these questions, the answer was a simple no. You don't need it. It hasn't existed forever. You all have been building businesses without it for a very long time. You probably don't need it. So if that's all you really wanted the answer for, feel free to leave. It's fine. But it doesn't mean it doesn't add value in some places. It doesn't mean you might want to know how it works. And if you're looking at edge AI stuff, if you've been watching any of the NVIDIA keynotes or what they've been doing with products, you'll see on almost every one of NVIDIA's products about AI, they put Kubernetes as a layer in there on how you should be deploying this. So the real question ends up being something along like the no. Like maybe, like, do you need it? Maybe in the future. Let's just figure out how this works. And I want to just start from very basics to make sure we're all on like a level playing field. And again, I'm going to whiteboard pretty much all of this. Despite being an AI talk, I am kind of sick of AI-generated art inside slides, if anyone else is there. This is going to have none of that. It's going to be super ugly, and because I'm just going to draw it all right? So no AI here. But let's say, whoa, that's a fancy glitch. All right. Let's say you have an app. All right, I told you, it's gonna be really ugly. What do you need to run an app? Not an edge, not with AI, not anywhere, just what do you need to run an app? Anyone? You need a computer. I got a Raspberry Pi right here, right? Like this is just, you just need basics. You need a computer that actually pushes electricity and your app can run on top of, right? You need hardware. I talked to some people at this conference that they were telling me they started their career writing assembly and COBOL. I was like, that is amazing. And in their case, that's all you needed right there. Your assembly and the hardware, and that couples those things together, and you can run that app all day, every day. It's going to be super performance. In 2025, anyone doing that anymore? Probably not. Pretty much everyone puts a shim in here called the operating system. And it separates out the application from the hardware so that your app can run on different types of hardware. And that's it. That's what the OS is for. It just says, I have something that I want to execute. It needs to execute on a CPU. How do I do that? Somewhere in there, you're also going to have a library of some sort. Maybe it's Python or Ruby or glibc or something that ties in with that operating system that just says, my app is going to run on this hardware. I want an OS. That's it. All on the same page here. Why don't we just do this anymore? At some level, especially at the edge, like it just, people hate driving. They hate going out places. So we said, all right, what if I have 3 computers? Because I want redundancy. I still have my app. I still want that to run up here. And I still need an operating system. But now, we put a new shim in place, just like the operating system, called a hypervisor. That's going to look terrible. It's OK. You all know what it means. And that's your hypercore. That's your scale computing. That's the piece in there that says, hey, if something actually happens to this computer, I don't want to have to go out there and fix it, right? It should be highly available. So we add this shim here, this hypervisor, so that we can move these things around. And we're doing that by taking this whole operating system and saying, actually, now you're going to run over here. If that machine goes away, we can still be available. Everyone following still? This is just, I mean, we all live in it. So hopefully none of this is new. I'm just trying to show the layers we're adding and the value we're getting out of those layers. Now, let's say you have a new app. You have an AI application. What's the very first thing you need for an AI application? Not a GPU. First thing you need for an AI application is you need to go buy NVIDIA stock. AI applications just do one thing over and over again. They need accelerators, and the best accelerator is NVIDIA's stock. Okay, so we all on the same page. So if you haven't done that yet, open your phone, open up whatever, Charles Schwab, whatever it is, and just go buy some NVIDIA stock. Then go buy a GPU. Okay, this is the accelerator piece of it. And the only thing we're doing here different is this CPU does one type of math really fast. It says, oh, if our application, 90% of this AI application is going to do one thing. It's going to do matrix multiplication over and over and over again. And CPUs aren't actually that great at that. GPUs happen to do that really well because they're just showing pixels on screens. That's the only difference here. So if I have a GPU and a CPU, let's go ahead and draw this out. Let's go back to I have one hardware. I have one OS, because we just want to simplify this again. And now I have this big old GPU over here. And I still need some of these libraries. Now, when my application says, I need to talk to this accelerator, what do? We plug in this GPU through the hardware, through the OS, and it presents itself to my application. And so when my application is calling CUDA, which is the library to talk to a GPU, it just says, oh, that path goes down to this device. And the OS is abstracting that away from us and saying, hey, you have devs, NVIDIA or dev GPU, whatever, to get to that thing to run execution on. And it's going to be the exact same thing for 3 nodes. But one difference here is, let's go all the way back. There's our hypervisor. Here's our OS. Here's our AI application. And here's our GPU. Right? And now, if this machine fails, this application can't go over here unless it also has a GPU. Right? At some level, I need to have the same redundancy in hardware. But if I'm only running one AI application, that's a lot of overhead to be able to do that. Say like, these are not cheap, and that's why you go buy the stock first. This thing here sitting idle is not helping you out, and it also doesn't have some of the nice things that CPUs have had for a long time, such as time sharing, right? Like being able to just back in the mainframe days, we would share the CPU over and over time. And GPUs don't have all the ways we can dice those up. So we have to figure out what is the trade-off we want here for how much GPU we're using for those applications, how much value are we getting out of them. Everyone still with me? Just going through this stack again and again. So we add a new layer. Get our hypervisor here. Just call HV. We get our OSs. And we need a couple GPUs. But at some point here, we can say, what if we had essentially a hypervisor for applications? What if we could put a layer between the OS and the application so that the OS below it I don't care about? Just like this OS gets abstracted to the hardware by a hypervisor, I can have an application here that gets abstracted to the OS, and that's essentially what a container does. A container just separates out your application from the OS so that it's portable, it can run anywhere. Lots of people I talked to this week, they said, I don't need Kubernetes because I have VMs. It's like, that's great. How does your application get on that VM? And in most cases, they say it's an RPM or it's a deb. I ship out basically a zip, out to those places, and then it runs. It's like, that's great. You could abstract that a little bit more, and you can put that RPM or that Debian package inside a little box, and you can now run that anywhere a container runtime is. And it abstracts away even the base OS. So now the base OS becomes less of a snowflake. It becomes easier to manage, just like all these hypervisors underneath are, or all these hardware pieces underneath are plug and play. I don't actually care. If one fails, I just go buy a new one, I plug it in. Everything will kind of come back up for me. Hypervisor and everything else goes on top of it. If one of these operating systems dies, I don't actually care. They're all treated the same way. One container runtime is the same as another. This shim is called Kubernetes. Kubernetes lets you do that across multiple OSs. It actually doesn't care if those are on the same hardware. Like if you're running a single node Kubernetes cluster or multiple, if you have multiple operating systems, you can separate those out. And one of the jobs of Kubernetes is to do the same thing that your OS does for hardware by taking this GPU and passing it all the way through to the application. So when your application says, where's my, that big blue thing is my libraries, my CUDA libraries, says I need to call a GPU, it can now call through that entire stack to say, how do I get to the hardware? The other nice thing that this is going to do is if, like I said, this operating system goes down, this application moving to another VM is a lot smaller, which is something that I talked to a lot of people this week. When a VM migrates, it's usually tens of gigs, maybe more. When a container migrates, it's usually hundreds of megs. And so the speed of being able to go from one machine to another is usually a lot faster just by not having to move as much data around. So when people ask me, do I need Kubernetes? I usually ask them, do you have a problem with speed right now with VMs? If you don't have a problem with VM speed, migrating, deploying, you probably don't need containers and Kubernetes. It's just not a thing that is affecting you in your processes, in your workflows, in how things get developed and pushed out. Totally fine. The reason Kubernetes kind of exists in the cloud is, or people think it like starts and works well there, is because they scale up and down dynamically. Because they're not buying hardware and sticking it in a store for 5 years. They're buying little bits of VMs every half hour or hour. And they say, oh, when that thing goes down, I want to be able to migrate quickly across those things. The last thing I will say here is, I don't know what color to use. We're going to draw a whole box around this whole thing. Let's say you have a bunch of these. Say you have multiple sites. Right? You have all of those things packaged up multiple times. This is what you're getting with Fleet Manager. Right? You can say, I can do that stack multiple times over and over again at different locations. I can centrally manage them in different places. I know the containerization stuff that's coming in Fleet Manager is going to allow you to deploy a container into those environments. So you don't even worry about most of this. Ideally, everything below this like Kubernetes layer, ideally you don't care about any of it. Ideally you just say, I have a container, I need it to run somewhere. All of that stuff should be hidden. That's what most people want. They just say, hey, I want a new way to deploy an application. Here's a container, it runs portably on any operating system. Just put it out there for me. That's what Fleet Manager is giving you in this case when you say, I want to run an application. Kubernetes is, like I said, a hypervisor for applications. It's a new layer of abstraction. It does a lot more than running a single container. It does load balancing and storage and access control and networking and those sorts of things. So when you try to say, I need more controls around an application or an environment, or I want to run multiple different user jobs in a single environment, you have to be able to have all these controls and knobs just like an operating system has today. Or an operating system, we say we have different users, we have permissions, we have home directories, things you can and can't do on the OS, Kubernetes does across machines with applications. In that case, you need a separate Kubernetes layer of management. I don't know if Fleet's going to be doing that with the application deployment stuff, but there's other Kubernetes management solutions that'll do that in multiple locations. We happen to have one called Omni. But that is the two layers that you need when you're doing this over and over again for different layers, at the hypervisor, at the hardware layer, at the application layer, at the Kubernetes layer. That's all you're doing over and over again, and why we're adding any of these layers at all. Hopefully, they're adding some value. If they're not adding value, you don't need them. I have way too many people that say, I need to use Kubernetes because I was told to use Kubernetes, or it's the thing to do, or it's AI. And I'm like, nope, if you're not getting any value out of it, please do not. You will only add confusion and more complexity. But again, if you have slowdowns, if you need to run in multiple environments, if you want to separate out your application from your OS, it might be a good idea. That is all I have for the talk today. Any questions? And Dave said he's going to help me. Kubernetes related, anything, applications, AI. The AI piece is, again, it's super simple because it's just the accelerator attached to a workload. Same workload. Yeah.
Yeah, I'll answer that. So yeah, it's a hosted service. We're currently hosting it in Google Compute, Google Cloud. But yeah, to you, it's a service. We could move the back end. You wouldn't know or care. And yeah, to address some of the application deployment, ultimately it is our direct. Well, today we've shown the zero-touch application deployment, which is preview, moving towards beta, where we're deploying in mass virtual machines declaratively through a manifest infrastructure as code. We can deploy Talos Linux, which is their Kubernetes distribution. We can deploy it connected into their Omni control plane. So there's a lot of these capabilities that exist today. As Justin mentioned, one of the things we'd like to do on those little boxes is make it to where you don't have to care about that Kubernetes layer. There's maintenance, there's monitoring, there's overhead. It does a lot of great things when you need those things, but it's another thing to manage and patch and so forth. And if you've ever run Kubernetes in a cloud environment, generally you can get a managed Kubernetes service that handles a lot of those things for you. So your developers just say, here's the containers I need to run and how many replicas and how they all connect together and how they store stuff, and the cloud takes care of that.
Well, and I will say too, I worked at Amazon on EKS for 4 years.
Yeah.
And there are things we take care of, but in almost every managed Kubernetes offering, it's just a managed database.
Yeah.
Kubernetes is just a database with an API. And so what we were doing on EKS was giving people a database with an API. Yeah. And then all of the upgrade cycles and the integrations to the rest of AWS was on customers. And so the thing we demanded as a EKS running that service was you had to upgrade that 3 times a year. And that became very difficult for a lot of people to say, hey, actually I have 150 apps here. I can't just roll out a new version 3 times a year to make sure that that's running. One of the biggest pain point that we had over and over again was doing regular upgrades was very difficult. So when you own the stack, when it's yours, you can decide, I don't want to upgrade during the holiday season. and you can then figure out when and how you're doing those upgrades later, which was one of the big things that we saw people pulling back from managed services by saying, hey, this is easy to get going, but it's really hard to maintain. Yeah.
I bought a little more NVIDIA stock.
Sweet. Yeah, before you deploy any of those GPUs, get some stock.
So I had a question about the deployment and the updating of those applications. How easy is it to, let's say you deploy a new version because there's a minor security fix and then it encounters some unknown issue. How easy will it be to revert back to the previous version?
How easy is it to revert to previous versions
In case you encounter something.
if you have problems? So in the container worlds, usually we add health checks to things, and I will say that health checks are ideally allow you to automatically roll back. Most of the time they don't work. Most health checks are very rudimentary. Like, hey, is the API endpoint up? Yes. Is it working? I don't know. Right? Like, you don't know for sure if the application is doing what you expect it to, especially with something like an AI app, right? Like OpenAI just rolled back their latest models because they're like, actually, that was bad. So like API's up, not doing what we wanted it to do. So how do we make sure we do those rollbacks? The rollback itself is, again, it's more of a speed issue with containers, where it says, oh, I don't need to do full VM snapshots and restores. I go from each container version is its own snapshot, hundreds of megs, hopefully. In a AI GPU world, it's probably gigs, but maybe not, but shouldn't be as much as VMs. And so in that case, doing the failover, Kubernetes usually will start a new version and not even kill the old version. It just doesn't route traffic to the old version. So it still is running. And so in that case, usually it says, I'm gonna keep this around a little while until I know for sure that you want this new one. If you have 5 replicas of it, it'll start rolling one by one and say, hey, I'm not gonna start killing off all the old versions until you're happy with the new version. So you can have some of those triggers in there. Kubernetes adds a lot more application-centric hooks to make sure that my application is healthy, not my OS is up, which is what usually when you're dealing with the hypervisor layer, where you say, oh, kernel's running, OS looks like it's doing work, I should be fine, right? In Kubernetes, we say, no, we want to make sure that we can curl an endpoint, that we can do some exec test to make sure that's valid. But you can have a bunch of knobs there for applications to say, keep AB running both times, and then turn it off when I say, do another webhook to have someone else figure out when it should go down. But the rollbacks are usually super fast because the images still exist on the machine. You don't actually have to, it doesn't like wipe them as it goes through a rollout. So you can have multiple versions. I know in deployments you can even say how many old versions you want to keep around. So like I want 8 versions around, and I have had outages in the past of keeping too many versions around and filling up my hard drives. We're like, oh, I forgot to clean that up. So yeah, there's definitely controls that are application-centric in containers.
And depending on your complexity, there's great tooling around Kubernetes that, can automate all these and, mass deployment strategies and, canary deployments and monitoring. And, if you're, deploying a complex application or deploying the same application across a fleet of 10,000 clusters, things like that. So there's a good ecosystem that can help with that. You maybe covered a little bit. There's also outside the application, there is the Kubernetes layer itself. There's, the operating systems running, the container runtimes, things like that. And there's, a range of, in the other container section, we showed you can build your own. You can take Ubuntu or Red Hat and load your, your runtime and pick your Kubernetes flavor and so forth, where you kind of own it and all the pieces. There's, more streamlined and I would highly recommend if you're exploring a Kubernetes, take a look at Talos Linux, both their open source stuff and the versions that connect up into Omni. They'll give you a free trial usually to kick the tires. We've had people who have never deployed Kubernetes and are just learning about it, get up and running and, running applications in 15 minutes. And, it's a great way to learn. Their technology does a lot of things in terms of helping, when you upgrade their operating system, which is very slim, it's, got automatic rollback essentially. Yep. I mean, if you try to apply a new upgrade and it comes back, it'll just roll itself back and say, hey, I had a problem.
Yeah, we can get as complex as you want.
Yeah.
But again, if these layers aren't adding value, then let's just remove them. And that was actually one of the ideas with Talos Linux that we built was, what if the distro only did one thing? What if the operating system only did Kubernetes and nothing else? What do we need to do that? And if you've been by our booth, you'll see there's a jar full of jelly beans, has 2,500 jelly beans, I think, in the large one. And that's a typical Ubuntu system has about 2,500 binaries. Talos Linux has 20. We don't need any of that stuff. We're like, actually, we don't have systemd. We don't need any of this stuff. We just have an init system that runs a container runtime and a kubelet, and then everything else is basically for like partitioning hard drives. That's basically the entire operating system. It's like, actually, if everything's containerized and this hypervisor layer abstracts the application from the kernel, then I don't need anything in between. You package all those libraries, everything else in your container, and bring it as you need it. So when you're doing upgrades, we just try to reduce as many layers and things in the stack as possible. So automatic failover updates, that sort of stuff. Yeah.
Do you have a third version of Kubernetes? Because a lot of guys using either Red Hat, OpenShift, or they're using Branch or something like that. Do you have something that preferred? Because OpenShift brings a lot of complexity that's about it.
Yeah, a question about OpenShift versus Rancher and different versions of Kubernetes. One of the things is all of those are distros of Kubernetes. They all claim to be a distribution of Kubernetes, which is in most cases, they build Kubernetes themselves and they modify Kubernetes. EKS has a flavor of Kubernetes called EKS distro, and that is literally their version. They build the whole thing from source. In every case, they all have their own tweaks and things that they want to do for whatever use case. Talos Linux, we don't have it's not actually a distro. It's just it's Linux with vanilla Kubernetes directly from GitHub as the open source community builds it. And so depending on how many layers you want in your Kubernetes, depends on what you're looking for. So an OpenShift is going to have all the bells and whistles because it's a platform. It's more of a platform than a container orchestrator. They're going to give you a Jenkins and build things, build infrastructure, what they call build packs. All these things, they're like, if you have nothing, you can go with this. A lot of people love getting started with that, and then they start peeling away the layers and like, actually, this layer doesn't add value to me because I actually have something else over here that I want for CI/CD, or I have user management over here, and so one of the things that is usually a problem is the more layers you have, the more complex it is to do those upgrades. And if you've ever been through an OpenShift upgrade, I've done some of those in my past, and those are multi-day events that are scary, and I don't know if it's going to work. Yeah. Yeah. So that's one of those things, as decide what layers you want, which pieces actually add value, and every one of those Kubernetes distributions are going to have some other amount of layers and some things that they focus on.
And they may run on certain operating systems, so you have to pick that, and so forth. Obviously, OpenShift is going to run on their Red Hat and their derivatives.
Yeah. Rancher's going to run on the SUSE stuff, and so all of those things, they're going to pick their own stack all the way through that they can support. Yeah. And that's where you kind of find your, not allegiance, but basically like, hey, who do you like getting support from? Who's adding value? And then figure out from them, okay, well, if you're already a Red Hat shop, it's going to be hard to go run Rancher sometimes, even though it might be compatible. Yeah.
But if it's not clear, I mean, Talos Linux from Sodero and the open source is an alternative to those. So you would pick that and get a, out of the box, ready to run, easy to maintain, not all the services that come along. They let you pick your own services that you want and so forth. But, if you want to get up and running with a well-supported, super secure, super lightweight Kubernetes, I mean, go ahead, say it's your favorite distro.
I mean, you're selling better than I am. You just keep talking. I don't know.
So.
Yeah.
Could you explain Omni to us quickly?
Yeah. Here, let me show you Omni. I actually have.
You may be out of time, but.
Am I out of time? I guess I got 2 minutes here.
Oh, good. Okay.
This is Omni. Omni is just like a web interface for connecting all of these different clusters. So you usually want Omni when you have multiple locations, multiple clusters, multiple nodes in locations that maybe you don't have access to. Similar to what you're getting with like Fleet Manager, where you say, hey, I can get this from somewhere. Omni, we run it as a SaaS, but it also can be run on-prem. It's a single container. So the whole thing you can just go run on any host, just do Docker run, you get this interface. Yeah.
And for what it's worth, with Omni, if you do the Omni trial, get set up, you can right from there generate a bootable image, either a QCOW2 file that you can import right in as a virtual machine to HyperCore. You can do an ISO. You can pick, I want to have the QEM guest agent so I can get IP addressing. Spin up 10 of those on any HyperCore cluster you want. They'll magically show up in your Omni portal, and you can just click, create a cluster. I want a single node cluster here. I want this 5-node cluster with these 3 as my control plane, these 2 worker nodes. Boom, gone, and you've got a Kubernetes cluster that you can connect to remotely through Omni as well.
Yeah. And so this is actually my home lab. This is running in Los Angeles. This is my home lab cluster. I redeployed it just before I came, but it's 5 nodes that's all connect into Omni, and I get things like I stream my console logs directly to the web interface. So because we control the OS, we actually can, once the init system starts up, start a WireGuard VPN tunnel back to Omni and just say, oh, we get all the low-level details we want. If I want to go in and say, upgrade my Talos version to whatever the latest version is, I can do that. I click a button, and it's going to do all those checks that we know we need. Everything in Talos Linux is container-based because that's all we do. So it's going to download a new container. It's going to reboot to the next version. If one of those fails, it'll roll back for me. It makes the whole, I keep saying these are the most boring demos because I click 2 buttons and I'm like, well, yeah, that used to be a week of work, and now it's just so boring because there's nothing to it. And so that's one of those pieces that once you start getting to this like, hey, I want a centralized place, if you want user management, if you want like automatic etcd backups, I don't have any set up here, all of those things are what we do in Omni for enterprises. And so Talos Linux is completely open source. Lots of home labbers love us. Lots of people get started, they try it, and they say, actually, why isn't Kubernetes always this way? And then once they start rolling it out to an enterprise environment, multiple locations, dozens of clusters, something like that, and they're like, I want a centralized place to figure out how all these things are working, make the OS updates and Kubernetes updates just easier. I think it's still going, yeah. That one's rebooting, there you go. So they just go through and they reboot one by one. Same thing with Kubernetes upgrades. It just goes, and it doesn't even matter. So. But I think that's my time. I am still around if anyone has questions, and thank you very much.